I think we have several weeks left. So I will touch on a new topic. It's about the social network analysis, and also I also put one of contents on our Moodle website. That's related to um, your uh, the Neo4j. If you can probably see the Neo4j stuff, then uh, in your website, the courses website, and maybe for UPT student, well, I actually put it on the Google Classroom, so it'll be different. But for our graduate student, that is putting on your Moodle system that is a code installation Neo4j. And so I was going to talk about what's a social network analysis, some background knowledge, and where I will also want to introduce you that there's one of the database is a social network style or networks of Grab. They call Grab database, and I want to introduce it before. It's a Neo4j that you can have some practice you can work with. Okay. All right, so that's for today. I already send you a slides. I will spend a bit of time to go through the presentation slides, and that will be some of the background knowledge you probably want to know. Okay. All right. I think we all know that we are living in very complex networks world. And it's a human relationship. People know these people. You know enough people in social network. That's a common network, and that comes with the notes. For example, if you have Facebook or the social network, I'm an individual person, right? I know some people, and how do I know that? If I know, that's a link. So no matter it's Facebook or maybe a LinkedIn, it's a very similar like this network. Okay. Usually not regular, it's not, but not random, right? And scale free. That means it can be very big. For example, some people have a very huge network, but some people maybe have a very limited. Okay. And there are so many different ways to talk about this kind of network. So, for example, the one you see here is talking about a financial institute. For example, there are all the name here. Probably you might know some, but you probably don't know everyone because we probably don't know that much. But if you can see those links between the Morgan Stanley with the HSBC. Actually, HSBC is a Huifeng Income. That's one of the international bank. So they are talking about the relationship between them. Okay. Here is very obvious. Is we use probably for some people use it every day. It's some kind of network, right? You know which node, which station to another station, and also there are a lot of information based on that. You come with the time. Also, you come with the distance, maybe come with a station and node also. This is from Taipei metro system. Okay. And sooner or later you will see this network is banned, right? As I know, in the future 10 years we have like 2 or 3 and maybe more lines we build and we connect with everybody, all the other line. So at that time, probably you right now we see that the very obviously different color, right? Red and blue and green and yellow, but sooner or later maybe they have different color needed, right? For example, pink, for example, different color, right? And maybe it is not easy to tell, right? This is a red one, and there's another red. Okay, maybe. So a purple one. Okay, you see different one. All right. So that means the network is getting bigger. So this is a particular for the biological protein and protein interaction network. I actually don't know what is that, but the detail is talking about maybe the different color that identify the different interaction among protein, and the protein have a different action with others. Okay. And that is this one is interesting. This is we call it history of philosophy. As you know, maybe we need to make it bigger, but I don't know. Maybe you see in human history, there are some very famous important philosopher. and maybe it's a Hegel, is Karl Marx, and some people was Aristotle, and there's Plato. Okay, Plato. I said that's something correlate with other people's idea or concepts of maybe philosopher, and that link. Okay, and you see the major different color maybe showing the major different identity, identify the different philosopher. Okay, and then the relationship. Okay, it's all about network, right? So why we want to study a social network, and basically it's so because we have social media, and right now they are networking. Okay, so there's a social network coming out, and right now, as you know, maybe 2 over 3 of the global internet population actually visit social network every day. I'm not sure if you did take a look on your IG every day. I don't know. But for me, I don't really look at the IG very frequently. I seldom open it. Probably, but I really take a look on my Facebook. So people say, hey, young people look at IG and old guys look at Facebook. Okay, obviously I'm an older guy, right? That's for sure. Okay, some people even think about here is information. So 78% of people trust a recommendation from other consumers. For example, um, that that's something. So if I know you, I recommend something to you that will be easier for you to be accept, right? That's very common, right? For example, in our lab, there are several students together, and people think, say, how do you think if that is it good to eat? For some kind of cookie, and it's good to you. Maybe somebody give a comments, and the comments say, yeah, you will really want to take that advice or the recommendation. Okay. And also, as well, I just mentioned that more and more people spend a lot of time on the social network. They are maybe posting something and take a look on the other response. So that's very important now, especially for social network. And don't even mention that more and more people and more system, for example, Facebook start to selling something, right? And you know, a local market, right? They sell something. So that they're trying to social network software company. I'm trying to find trying to scratch the profit from the social network, and not only the advertising, and also by other transaction. You can probably see more and different activity based on that. And also there are a lot of relational methods, similarities to understand. For example, our social network analysis is currently very important, especially for politician activity, right? If you a campaign election, so monitoring the social network opinions is very important, right? We also looking at some opinion key opinions would be very important because their opinions will probably guide this a group of people to follow a certain opinion direction. What I mean is in Chinese is a 带风向. I think you probably know the term. That means we try to manipulate the way how people think about something. Okay, okay, and that's all happen all the time, right? It happen all the time. Currently, I think the social network is the analysis, or maybe the social network war, is still very important now. Too many people looking at that, so some opinions actually drive the political or the economical decision making. Okay. So right now, the social network access also embodies a range of theories related to different types of the social space, and a lot of research and methods are actually working on this area. Okay, all right. So as you can see, this is a plot. That's very obviously that from the United States of America. There are two-party politician system, right? the Democrat and the Republican. So and some of yellow one is probably in the middle one that's no belong to particular party, and but their opinion might be identified, um, and so that's a very common. And this one is interesting. Is talking about relationships of people, different group come with a different group people and colors, and they're very different. Okay, and that's linking map has also that's one um, the people has a different group. Very early time, I joined Linkins even when I was a PhD student when I was in US, and that's the very first exactly Facebook. The very first link social network I joined. Because at that time, some professional, even academic work at the academic job, they look at your LinkedIn. And so we spend the time to update my LinkedIn page information and very detailed. Even we talk about how many people I published or something like that. Yeah, but I seldom to update it now because obviously I got a job already, right, for a long time. But if you know that I'm not quite sure in Taiwan, but there's still some people, actually human resource people, look at the LinkedIn in Taiwan and globally also. So they are very different group. And our school of management even purchased one of LinkedIn academic study that will share a lot of resource, useful resource for LinkedIn in LinkedIn system. Facebook, I won't even mention that. And this graph, every time I talk about that, you can see how interesting. But it's come from 2010. Obviously, we see in the middle that's African, right? Obviously, no, a lot of people are using Facebook. And if you look at this world, you will see some of the certain area here. It's quite huge. I'm not sure. Do you see huge here? Where is it? You can probably guess, right? Uh, I think it's in Russia. I mean China, right? It's one of the area in 2010. Yeah. I think Facebook is still be banned in China, I guess, right? Okay. But in South, I mean, probably it's that big. Okay. It's that big. Okay. Sorry, I draw this one. Russia and China. Okay. And where we are right now? We're in I think here. Okay. In Japan. And where is this area? North Korea. And so obviously social network is not available for everywhere. But of course, it's debating. Some people think it's it's a tricky. They share not very correct information. We don't know. Okay, but no matter what, that's a huge amount of networks here. So what is network? Maybe we start from a very fundamental. We start from what is network and take a look at what and how we can use our social network. And some terminology have been used for the network. A lot of people consider it called graph. Okay, and known as a vertex and alter is probably the same meaning in some of similar terminology. And link it to the edge on relationship. We could talk about, and as class is a small community. For example, on the right hand side, let's grab. There's like it's is grab over there, and there are three groups, and maybe you can consider four, and that's an age and link. Okay, and lots of terminology is have been used for graph theory. Okay. A social structure make up the individual code node, and the link is can be defined. And it could be like a friendship, and it could be like a relationship. And some people even think this can be like employment. And I want to give you one example, also an interesting one that we have experience with kind of a company that actually told me that They're trying to study the special network among the doctor. And but how do they know? Yeah, not only from the how which university graduate, is actually also checked on the how those doctor, I mean, especially for academia hospital, how we cite the paper together, citation, right? And also what's the authorship, co-authorship, so also can look at some of detail about those doctors, the social network relationship. And why they want to study that? Because the study is come from one of the very famous pharmaceutical company, 药厂. Okay, because they want to sell something to hospital. If you can know the networking among those doctor, I mean, medical in the institute, medical institute, that would be very important. Okay. So here's a repeat. Here is node and link, and then you can consider not only friendship. There are so many different ways we can define what's a node, and we are different way to and also to determine what's a link between the nodes. Okay. And here is a very fundamental that, for example, if you consider friendship, that you try to define relationship. The node can be the 3 and 2 and 1. So here's the English terms for you to understand. There are multiple ways you can describe. And of course, when the relationship getting larger, so the social network, that means you have a finite set of actors on relation defined by them. And then you are able to use a graph or social graph. Here's the terminology here, and you can define the length of the time. Okay. And so there are very different way, and also in between you can have different weights on that. So we will quickly introduce you that knowledge. So here is the strength of the tile is defined by the directional or non-directional, right? So some of the relationship can be a direction. I know you, you didn't know me. Is that possible? Yeah, it could be. It's social network, right? But in physical, suppose hey, I meet with some people. Suppose we know each other at the same time. If that's our first meet, okay. But in social network, it won't be. Maybe you are maybe one of some of people that are very famous in social network, so we know him. But he probably don't know us, right? Because we have no interaction, right? So that is how we can define. Okay. And of course, there is some of the terminology you can say called isomorphism class is a null or maybe it's a mutual two people together. And also come with symmetry or asymmetry diane. Diane is our previous slide you say is a link, right? Okay. So it's you can see that there in graph theory they are already talk about this in graph theory. Okay. And but why I want to use a graph theory? The graph that I used to model the pairwise relationship between objects, right? Is it way before the social network popularity just have occurred in our human society, right? And generally, it's a defined network can be represented by graph, and there are many practical problems and can be easily represented by in terms of graph theory. Here, just to show you some example. I think talking about a history of graph theory, maybe you can went back to the 1735. It's probably a long time ago. I mentioned Leo Ham's wrote out this paper. It's called Seven Bridge of Königsberg. And that was a problem. Say, I think that's a very interesting physical. You want to go work all A7 bridge then in that certain area. I think that's a very small islands, and there are seven bridges around land. It's very similar Okay, I see. But we don't really have in Taipei City is not really an island in the middle of a river, and but you probably see so multiple bridges across a Danshui River and also Jilong River, right? So that we'll see. And you want to walk all of the bridges without crossing bridge twice. So it's a very interesting way. Maybe you want to go and go. Uh, Okay, I didn't get a solution, right? I just main example that what the original province. You want to cross a river and cross a bridge and don't want to walk on the bridge more than twice. Okay, so that's the interesting problem, but that can define by the graph theory. Okay, and also there are multiple problems. This one's called Hamilton's cycle of Platonic graphs. We call this called polyhedron. Polyhedron 是多角形吧，哈，多角形英文哈，polyhedron. Our polyhedron with a known Hamilton's cycle. Then you try to define the cycle, and I want to see how many cycle in the polyhedron and defined by this graph. I think every time I look at this figure, I do, wow, it's kind of beauty, right? You try to go through that and not cross over. So we want to create a cycle. As you can see here is really a cycle you go through, right? Go to that. It's a circle, right? It's a cycling. And don't repeat it, go to particular node more than twice, right? And no crossover, right? No crossover too, right? And if you know that electric circuits, electric circuit theory, as one of the very famous called Cauchy-Herfuhl. There's a circuit design. If you have that background, and we see that second kind of tree. It's also looked at like a network, right? And they calculate the voltage around the 2 points. Okay, and that is one of very famous theory, I think, in electric circuits. And this one is called four color of map. Okay, I think that's interesting. That it's a heuristic way. Maybe you find four colors of a map that cannot be uh, your color cannot be linked with everybody. So I give a map and put a color on that. I think that's for children. It's a very interesting job for them. So hey, don't try to put the same color next to each other, right? And you have four different color you can use. I'll give you four different color pens and can you find out? And maybe it's a kind of a challenging for them to say, they find solve the problem like this, but they do a little bit fancy here, color in colorful. Okay. So what is a graph? It's obviously a very similar definition, just one mention. There's a note, but probably on graph theory level more like to talk about called vertex, and also there are maybe more interesting node and edge. Okay, and vertex and edge. Okay, so it's a very similar idea. So and that's defined as size very similar absolute values, and you can define it. And so vertex and nodes is very similar, like what we just mentioned. Yeah, it's a very fundamental basis of your elements. And the agent arch is a set of two things. So you want to define and you have to talk about two nodes, right? Two vertex, and you want to define it. Okay. And the edge set of G is a particular one. Is denoted by some by they are in different books used in different way. And for any node, the set of node is connected to the edge. Okay, who linked with that is called neighborhood, right? Right? That's one that with a one. Maybe I have a multiple neighborhood. So here is just an example that you will see 6 different nodes and you see the 7 edge have been defined. So you can see the vertex can be defined and how many edges 7 sets, right? 1, 2, 1, 5. So it depends on what the graph do like, right? And the neighborhood so for the number 4, you have the number 4, right? You have a 6 and 5 and 3. as a neighbor. I think that's very straightforward, right? But advertising will make things a little bit more complicated, right? So if you want to find the undirected, and then you might have a way to define undirected, usually, for example, distance. As you already know, the class in math, we actually calculate distance matrix. And based on this distance matrix, well, let's consider if I'm on the zero distance with you, that means we are very, very close. And maybe you can define opposite way, we are very, very far away if you define it as a zero. Okay, if it's zero, then we have no way we can go to something like that. So this called undirected edge type. You usually distance is undirected edge type because if I have a 1 meter distance with you, that is also supposed to also mean you have a 1 meter distance with me, right? But sometimes we have the direct edge. They have source. It come from which origin to another destination. If you that's called direct type. And sometimes it's not direction, it's about a width. It's different. For example, this particular edge, we have a higher width on that, so that will be defined. So here is the example. It's called empty, edgeless graph. Okay, no edge, no link. Then simple graph is undirected. It's just simply linked them, and you didn't see any particular definition, or maybe you didn't see any words wanted to find on the edge. And that's as a direct edge. Some students say, hey, professor, it's very similar. We learned it before. It's a kind of Markov chain, right? Yeah, so if you learn the operation research people, and then we have some big ones. So we can define a loop, we can define the note, we can define the arts. And those are concepts you already familiar with, especially for the industrial engineering people, a student, or industrial management student that want to have a big one. So, and what graph is the graph that you can associate with that. So you put an actual number on that, and it can be direct. It also can be indirect. Okay. And sometimes we want to consider subgraph. That means it's a small graph, small cluster, and a subgraph that can contain. If you want to see the subgraph of one particular node inside, then we can use a way to define it. So that is one I will use to study. We call it adjacent matrices. It's one is define using a particular matrix to define if there are two nodes and are they nearby. Okay. So that is a diagonal entrance is a cell link of a lookup. So here is one example, and you can see it's a pretty symmetric matrix. Since it's undirect, right? So you will see one has a link with one and two has a link. So then put one and three has a link. Okay, and 1 and 5 is actually not linked. So you can so on and so forth. So you can see, and once it's a matrix, is actually you will see the number is as you go from right symmetric matrix. Okay. Okay, and so incidence matrix, you actually try to contain actual information and data. So this is a different way to describe. So for this case, 1, 2, 3, 4, 5, then total 6, right? And you want to identify 1, 2, 1, 1, 5, 1, 1, 3, 2, 3, and so you try to define the link. It's called incidence matrix. Contain similar information, but by different way. Okay. You can also define the adjacent list. Adjacent list is basically a known list. For example, as you can see here, edge list is 1, 2, right? We have a 1, 2, and there are 2, 1, 2, 2, 9, right? So you can list here. And if you want to define the adjacent list, so you can actually check with which one is near with another one, right? So adjacent list you can define. For example, for four there are two adjacent, like 3 and 5, right? For 5, you have a 3 and 4, and why not 2? Because you have a direction case, right? Uh, I cannot go from 5 to 2, but the 2 can go to 5. So that's why if we put a 2 here, you have 3, 5, because of that direction. Uh, shown in the adjacent relationship divided. Okay. And age list for wet is just a kind of make the definition a little bit more information. I would probably say that one can go to 2, yeah, because it come with direction and also come with the wet into. So that is just some of example I want to show, and that is usually from the front, and there's a 2, there's a destination, and come with a wet. Okay. I think it's very easy, right? And very easy to understand. So we have a different way to do so some kind of classification for grids. So we have global terms to refer to whole grid, and local usually mean the certain to a single node of grid, and that's referred to different range. And we also have a connected or isolated. Okay, the connect, and for example, this one is isolated. People just work along. Uh, in Chinese, we usually call this kind of person is called 孤鸟 嘛, right? 狗叫台语. Okay, so the same meaning is no any link with that particular note. Okay, adjacent note is already mentioned, right? Um, how to find adjacent note is also really depends on what your graph belong to. For example, your definition. So here is a to know adjacent connect with the edge. And so you are able to U and V, if U and V are adjacent and we belong to. So there are certain kind of algorithms help you to find adjacent node. They even have a little more extents to the how to find, give you a graph, how to find the minimum adjacent node, or maybe maximum adjacent node, something. Okay, then you are trying to look at the information that was showing in the graph. Okay, and sometimes I think already mentioned that it's a looping, right? Cell loop, right? Is I think it depends if you know the markup chain, you also can define that, right? Okay. A number of ages incident nodes usually called degree. For example, 5, we have 3 nodes, so degree 3. It really depends on the definition. And but if you want to define the degree for the directed graph, there are called one in degree or out degree. And in degree, out degree is somebody can go into your node and because it's directed, so indirect is the number of age entering and number of age leaving, right, out, right? And the degree will be in degree and out degree, they can something else. So here just example, for example, 1, there are 2 out degree because there are 2 out, but for the in is actually no, right? Nobody get in. So we use it as an indicator to define the direct grades. And here's a concept, what is it called? Walk is a path in which edge node can be repeated. So, and trails, there's, for example, no edge can be repeated for certain things. So here's a definition. I will just quickly go to that, and you can take looks. So path is a sequence of P of nodes. Okay, and a non-vertex can be so that if that's a closed path, we usually call cycle, right? You can go from that and return back to original, right? And here is an example, and also the length of a path or cycle is a number edges you actually visit, right? So, for example, you see 1, 2, 5, 1, 2, 5, 2, 3, 4. Okay, it's a what to the length, the work of the length of 5, right? And cycle work, let's take a look. It's a going cycle. 1, 2, 5, 2, 3, 2, 1. You you can repeat, but in the end you go back to original one, right? So 1, 2, 5, 2, 3, 2, 1. Let's go back. And the path is of a length is 1, 2, 3, 4, 6. So you just go to from there. So it's one kind of path, right? Not repeat. Okay. And circle is very easy to understand, right? You come back it curls to it's kind of close in the end from here to here, and so trying to find a circle thing. Okay, so there are only 3, and then 4 and 5. Okay, so here just want to summarize what the works on trails and paths, and I think that is you can take a look on the definition. I don't want to go to detail here, but at least you will see that you're actually counting how many, try to count how many edge in the work, and work is a particular term, right? Work is a particular term for the direct on your directed. If it has a direction, it's a sequence of nodes and lines starting and ending. Okay. So you use this definition, you can define some of length of the work of the, and you will define the trial. And trial is one kind is a work in which not all distinct, right? So that's here. I'm sorry. Here is a definition just for you to understand. In graph theory, we have a multiple way to define it. So you can come take a look. So the path is one of the trail, and every trail is a walk, right? And why? Because it's a logic, right? Based on the definition. So here just to show you example. Say, if you based on this graph provide, and you can see there are 6 different nodes, and there are 7 different links. Okay, so you can take a look on what the works as a N1, N1, L1 to L2. So you kind of link to all the information put on this information we can define in graph theory. And shortest path that's related to the optimization, right? It's a path between the 2 nodes from A to B, and which is the shortest path. And that is usually, if you learn this from the operational research, is also you find, right? The problem you find, how can we optimize the distance, the path, logistic, right? And that would can be length and is the distance. Okay, and the diameter of the graph is also the length of the longest shortest path. So, but why we say this is a very strange word? It's not a mistake. It's actually to find that you want to find the from A to B the shortest path, and I want to see what is the largest one of the shortest path in that one. That's what we usually call that the diameter of the graph. And of course, here's a more differential reachability if it has a path between these 2 nodes. That means no matter how short, how long, and it can be reachable, right? It can be reachable. And a geodistrict is the shortest path between 2 nodes. So that's the definition. And the length of the geodistrict distance is we can call it distance. Okay. All right. So why I want to talk about those differences, I just want to give you an idea. So yeah, in graph theory, I have a very well developed design. They already have fundamental knowledge for you to understand those network. If you wanted to find network on that, so the edge, and you have a very different way to describe a word, a path, and circle, and based on the directional or not directional, and you can put it where so you can study. And we use a lot of fundamental knowledge to define the social network and data if you can collect. So sometimes you will consider that's undirect way. For example, distance, and you put a what on it, you put a distance. But sometimes, well, just what I just mentioned, if I know you, you know him. Okay, and if you it's just not by direction, maybe I know you, you didn't know me. Okay, I borrow money to you, you borrow money to another one, but it's a that's a different way to describe the activity. Okay, you probably heard of one of a very famous term called 6 degree of separation. Well, that's somehow that's a way that people say any two person are in average separate by no more than that's a 6 individual connection. What does it mean? It's been talking about by this way, say, hey, yeah, any two people in the world, so they definitely can probably see some people in middle, more probably more not more than six than one now. Uh, for example, I know you. I probably don't know you directly, but I know some people, and that people know another people, and that another people probably know that third people, and that third people know you. So that's kind of going to this link, and of course, it comes from one of even the movie or the books that use this a term called 6 degree of separation. So that's a one. So A didn't directly know that particular person, but he tried to find the certain person in the median, so they know and eventually reach to you. And how does this six number coming from? Is a very interesting. Why do people say this way? Are you curious on that? They said, no, why not is it five? Why not is it six? Why is it six, right? Actually, it comes from one of the theory, one of research, I would say research called the small world problem. It's go back to 1967. And you have to be aware, in 1967, we don't have a, we don't even have an internet yet, right? We don't even have an internet yet. We don't have and the research is done by the Jeffrey Travers, is from Harvard University, and another author is Stanley of Milgram from the City University of New York. So that is an experimental study on a small world problem. And that when you ask why people talk about 6 degree of separation, well, we can go back to take a look at what this research, how they did this research. But went back to the 1967. At the time, we actually don't have internet. We actually don't have telephone probably. So that's a research way that did. Oh no, I think we already have a telephone, I guess. Okay, but that actually did this way, and we can see. So that's a 1969 experiment. As a figure showing the United States of America. He wanted to do the um, check with 296 volunteers, but eventually only 217 people joined. Basically, we want to send a message, a postcard, from a places or from one person, and send to postcard, try to reach another person. And then here just want to show you the distance wise is the Nebraska. Nebraska is in Midwest. Is okay. Where's the Nebraska? Nebraska is over here. Okay, and Boston. Boston is in Massachusetts. Massachusetts is somewhere here. And you have to consider that's a very far away. Okay. If I'm not wrong, you want to take an airplane from Massachusetts, Boston to the Nebraska. I think probably need to take 3 hours. Okay, okay, that's a distance. It's not very uh, nearby. So basically, when they send how they did is how to take part in this study. It's interesting. And your name on poster on the boat bottom of the ship. So it's kind of a you put a piece of paper maybe and you write down your name every time, and so that the next person who receive this letter. So you send a letter, for example, send a letter to you. And what you need to do is put your name on a piece of the paper in the bottom. So you continue to put that. And detach it on the postcard. At that time, do you know what is a postcard? I even talk about this. What's a postcard mean? Then why do we use a postcard? We don't really use it now. I want to give you a very interesting story I heard from a long time ago. For example, in university, uh, for example, the university I studied in Purdue, and they even showed one of the story is a long time ago how to communicate. For example, one professor want to invite another professor to join a lunch meeting, for example. And what did they actually do? That they don't have a telephone at the time, so he basically write a postcard. Say, hey, David, can you join me in the dinner? And send a postcard. That postcard go to the mail. It's kind of mail system and go to the person. And that person will say, okay, I am fine because no telephone, by the way. So you return and it's write on the postcard and return it back. So, it's a very, ancient time, right? So, oh my God, how did they do this way? But that's then. And why I know because it seems like I watch it like I go to a museum or something and university museum. They show that postcard about the professor's communication. This is very funny for we probably have no idea about this why they do this, but at that time you think about no telephone, no cell phone, no internet, no email, no messenger, no any kind of tool. That's the only way I probably can do it. Maybe you can help out the animal, right? There's some kind of bird or some pigeon, so you can send a message to it. But we are talking about the postcard system. So you detach a postcard, fill out, and return to the you know Harvard University. So you kind of send back, uh, and why they want to do that? We're asking if there's a target person. If you know that person, then you can actually direct send to him, right? That's important, right? But if you don't, then you want to send to some people you guess he might know him, right? And so that's how that tried the way. So here's the thing: if you know the target person, then you probably just direct, okay, go direct to him. If you don't know the target person, okay, on a person basis, do not try to contact him directly. So instead, the mail the vote to the personal acquaintance who is most likely than you to know, right? So it's a very interesting experiment. Sometimes when I introduce this to students, it's a very interesting. Of course, I'm gonna give you a background because no telephone, right? And so you send to some people who you think he might have more chance to know that person, and so you send to him. So you kind of try to find a link. So let's take a look at the experiment result that in 1969, and so it kind of reach the target end, and so the measure the average the length how much people get to that. So here's a two direction way. One is from Boston, one is from Nebraska, right? And you from maybe you from you probably say from Eastern Coast to the Midwest or something. But you have to understand Midwest and probably at that time, so you think it's very far away. You take an airplane not 3 hours at that time. Probably it's 5 hours or 6 hours, maybe. It depends on technology, the airplane, how the speed of the airplane at the time. So you can consider it's very far away, right? So the averagely you see, whoa, it's very close to the number. I said 5.7. Okay, from Nebraska to it. So they also should study this. So that number is very close, right? But it's a very small word, small. Like it's a total of 64%. And this small world experiment have been done after we have email. So in 2001, that's one of the researcher actually did. But of course, he have more sender. So send one person you might know, another person is sent to. So the average link is a 6%. A messenger have been done. It's 2007, and you or somebody did. And Facebook even in 2012, they tried more than like 700 million users, right? So it's a huge friendship the number and link. So so that's a multiple way that how the people to do. So is that the six? Probably not, but it actually very is surprising. So people already say it's a 6 degree of the separation, so they will keep using this six. I think that's my last slide of this presentation. So I want to introduce what is a 6 degree, how people say a 6 degree of separation is based on the conclusion. But here is we call the Calais trees, and here is an example. You think about what if you kind of want to measure how big the network could be. So here is a thing. So here is an example. You want to use it in mathematical so to define the first group of your person. For example, I'm in the middle, right? It's me. And if I only know 3%, and everybody can only list their 3%. So I am a 3%. And this one have a 3%. And why? Because this one have a 1, 2, 3. So if every single note can only have a adjacent 3 notes, so you kind of want to measure how big they could be. Okay. So obviously based on the calculation, you say 1, and because the 1 minus 1, because this person you minus the 1 origin come from, right? So it's a T. So you use a K defined by there, so and including the original first one. So you can measure total number on that. And that is the if that's, but of course that assumption there's the Z is always a constant, right? Connect to the neighbors. Okay. Then if you want to estimate that, you think about how many people in human history right now is very close to 6.7 billion people. Okay, so total N, if you know total N 6.7 billions, then you want to track back what it could be the L could be. And so if you think ZLXN, then N is a total number. So you kind of consider what's a total human population as a total number. And Z, if you say everyone has a 50 friends, so then you can estimate that L is very close to 6. It's a 5.68. But of course, it's based on assumption. But if you want to use Calais tree to try to explain why we talk about 6 degree of separation, and you can use it this way to estimate the result. Okay. All right. I think I already finished the slides for today. Maybe I will start recording. Okay. And it's a very